So we're going to get started and we're going to do some more review problems today. Let me make sure I'm in the right spot. I am. Okay, so go to number 15 if you're not already there. And we're going to do some more problems. And again, I'm debating a little bit about how I might change things up. And so we'll get to that. More than anything, I want to finish the packet. And then I also want to make sure you have enough time for the exam. And so we'll talk more about that. My fear with the exam on one day is like giving best effort for an hour and a half is a lot. And so that's why I'm thinking about splitting it, and we'll, like I said, you and I will brainstorm, and Miss Littleton will talk. Okay, given that we have f of x equals x squared. All right, so that's where we're starting. We want to do some transformations. So these are all separate from each other, so we're gonna kind of like start over and start fresh every time. So part A wants me to go left and up. Okay, so I'm gonna give it a new name. So it was called f of x. I'm gonna call it g of x this time because we're doing something to it, so it's a new equation, so I'm gonna give it a new name. We have two things that are happening to x squared. So I'm going to set up that much of it. If I want to move left 8 and up 9, what do I need to put in parentheses with x? So to move left 8, what should go in there? Huh? Plus 8. I love it. It goes in as the opposite. So there's my left 8, and then up 9 goes outside. So remember, things that are left and right go in parentheses. Things that are up and down go outside.
Let's write that down.
Oh, yeah, let's write that down. Let's go left and right go in parentheses. And then up and down go out back. Like the steakhouse.
Oh.
Oh. So again, left and right in parentheses, up and down, so vertical stuff, right? So another way to think about this is horizontal stuff and then vertical stuff. That's a good note to write ourselves. Let's look at part B. So again, this is like a fresh new problem. So I'll call this one h of x. Doesn't matter what you name it, just something different from f of x. I want to vertically compress by 1/3. So I have this x squared. If you want to vertically stretch or compress, we multiply. And remember, if it's something vertical, it goes out front. So all I have to do here is multiply by 1/3. So if you see a stretch or compression, if you see a stretch or a compression, then we have to multiply. If you see a transform, like a shift, then we're going to add or subtract. So again, that's another note you could write yourself on your sheet. So adding or subtracting if you're shifting or transforming. If you're stretching or compressing, again, that's multiply. Oh my, look at the next one. We've got lots of stuff going on. I'm going to call this one b of x for Bryson. Look, I named it after you. Okay. We need to shift right, so I'm going to need parentheses. Here's my x. Okay, so let's start by shifting right. What would I put in parentheses to shift it right 6? Yep, it's the opposite, so it's minus 6. Then I want to shift down 5. So what am I going to do to make that happen? Minus 5, and it goes just outside, yep.
Wait, why does every time you put different like letters than X?
Just because I'm giving them different names. So I did a transformation, and again, so it's changing it from f of x. So it was f of x, now it's something new. I'm just picking random letters. Yeah, it doesn't matter what you pick. There's no rhyme or reason. If I want to reflect it, do you see how it also says to reflect over the y-axis? Okay, so if you're going to reflect over the y-axis, that's going to impact x. So I'm actually going to erase my parenthesis and give myself just a little bit extra space because that's going to go here. So if you're reflecting over the y-axis, the x gets a negative. The x gets a negative sign. If you're reflecting over the x-axis, then the negative sign goes out front of everything. So we could write that too. So a reflection over the x-axis means a negative goes out front of everything. Okay, we've got some solving stuff next, and you guys got really good at this. So let's see how we're doing, because it's been a minute, but we were really good at this. Look at part A. Do you see how I have x's on both sides of the equal sign?
Yes.
Yeah, let's move those together. And I also see one other thing I'm going to tidy up as well. Let's move these x's over to join their other x friends over here. So how could I remove the 2x from this side? Yeah, let's subtract it. 3x take away 2x, what does that give me? 1x. Now, do you see how I've got this 15 minus 9 sitting here?
Yes.
What do we know 15 minus 9 is? 6, yeah. And if you don't know, you can always grab a calculator, right? Calculators are allowed for the whole thing. So 15 minus 9, that's where I'm getting my 6. 3x minus 2x, that's how I'm getting my 1x. This disappeared, so all I have left over here is a 4. So we did two things at once. We moved the 2x, we subtracted it over, and then we also dealt with this math problem right here and got 6. How can I finish solving for x and finish getting it alone?
But you
Minus the 6. So x equals, what do we know 4 take away 6 is?
2.
Negative 2. You guys are getting better at the math facts too, I feel like.
Mm-hmm.
Like questions that I asked months ago, I feel like it's like, oh, but we know this now. The more you practice, the better we get. Okay, part B. Do you see how I can distribute that 1/2?
Yes.
Let's do that. What is half of 6x?
I don't know.
Well, what's half of 6? 3. So if I had 6 x's, now I only have 3. What's half of negative 10? Negative 5. Okay, so that got rid of a lot that was going on. Like it was kind of a troubling situation. There was a lot going on. Now it's a lot easier. What can I do to move the 5 away now? Yeah, let's add it over. So I get 3x equals 15. And then how can I solve for x? Yeah, let's divide by 3. X equals 5. And it's, I don't know, Miss Littleton, I feel like it's kind of cool on our end because I love seeing how good they are at these things when I feel like, you know, when we started learning it, it's tricky and we didn't know stuff. And so now seeing how far you guys have come is awesome. Okay, let's do 17. You ready? Okay. Do you see how we've got things being divided by 4 and that looks kind of problematic?
Yes.
Yeah, let's get rid of that division by 4. How do I undo a divide by 4?
You have to times before.
Yeah, let's multiply each side by 4. Now, do you notice this problem is a little different from the last two?
Yes.
Because we have a gator, right? Instead of the equals, we have a gator mouth, we have an inequality. So that is going to impact things. Okay, these cancel. Negative x plus 7 is less than or equal. What do we know negative 5 times 4 is?
20.
Not just 20, negative 20, yeah. Okay. Next, how can I move the 7 away? Yeah, let's subtract it away. So I get negative x is less than or equal to negative 27. Now here's the problem. I have one little problem left. Do you see how x is still negative?
Yeah.
Do I want it to be negative?
No.
No. So I'm going to multiply each side by negative 1 because that's going to help me make x positive. I'm going to have to move up here because I've run out of room. Negative 1 times negative x is going to give me a positive x, yes?
Yeah.
Okay, don't write the gator yet. Negative 27 times negative 1 is 27. When you multiply or divide by a negative number, do you remember what happens to the gator?
It changes?
It flips.
Good job.
Yes. So let's write ourselves that note. So when you multiply or divide by a negative number, the inequality flips. All right, now I do want to do a decent amount more of problems on this worksheet today. We're going to keep going. Hold on, I want to see what it's, oh, okay. Let's do one more, and then we're going to take a little break, and then we're going to come back to it. Because I feel like, you know, I feel like we're getting to the max of our time that we're just like sitting and listening, and I just want to make sure I respect that. Okay, look at number 18. Do you agree, at the end of the day, if what's in this absolute value is 35, these two things would be equal?
Yes.
What if what was in here became a negative 35? Would that also be okay? Yeah, because the absolute values would right the ship. These are the problems. So when you have absolute values, these are the problems where it has to split into two things. Yeah, so we do 5x plus 15 equals 35, but 5x plus 15 could also equal negative 35, and that would be okay. So how do I know to do the split? So we split into two problems when we have absolute values. So split into two when we have absolute values. Oops, you can't see that. I went off the screen a little there. Okay, so we need to solve both. So that's the bummer, is it's kind of like now we've got two things we got to deal with. Okay. Yep, I heard Michael say it. Let's subtract the 15. I love that. 5x equals 35 take away 15 is going to leave me with 20. How do I finish solving for my friend x? Yeah, let's divide by 5. And I find out that x equals 4. Love it. Okay, other side. I want to solve for x. How can I get rid of the 15? Yeah, let's do it again. Same thing. So the only thing that's going to change is now we're going to get a different number. So if I have negative 35 and I take away 15 more, now I'm at negative 50. And again, you have calculators for the whole quiz, so you can use a calculator for this. Yeah, it's going to be 10, but will it be positive or negative 10? Yeah, so x equals negative 10. Okay, so those are our two answers. So I'm going to pause here. So no classwork today. We're just going to continue on with the packet, and we're going to keep working on that. What's up, Michael?
How many more we can have?
Yeah, that's a valid question. So here's what I'm thinking. So today, tomorrow, and Monday, we're going to finish up our packet. So we're going to have to do 2 pages each day. Do you see how we're almost done with this page? So we've got one more problem, and then we've got through here. So I'm going to go through 23 today. Okay? And then we're going to call it a day. All right, so it says rewrite in standard form. Ooh, do you remember what standard form is? Ooh, no, the y equals is vertex. This one is ax plus by equals c. So another way to think about that is things with variables go on the left. Numbers by themselves go on the right. So things with variables go to the left, numbers go to the right. So this is the equation though, this is the important piece. Again, if anybody wants to borrow a highlighter or anything, like I've got all these pens and colors and highlighters and all the things, come grab one if that would help you as you're doing these. Okay, do you see how one of my things with letters is on the left?
Yes.
Okay, where does my 3x need to go though? To the left, also to the left because it has a letter. So I'm going to take my 3x and I'm going to subtract it over to the other side. Now, can I combine the 7y and the 3x? No, they're not the same letters. Like, they're not the same thing. So on the left, I have 7y minus 3x. And on the right, I still have 15. Are all my letters on the left?
Yeah.
Are all my plain old numbers on the right? Okay, so I'm in standard form at this point, so I'm going to write it in the blank. Standard form, 7y minus 3x equals 15. If I wanted to, could I flip this order so the x term comes first?
Yeah, you could.
Yeah. I don't care if you do that or not, like I just want those on the left. All right, the a value is what's in front of x. What's
3.
living in front of x? Careful, not just 3, negative 3.
Oh.
The b value is what lives in front of y. What's b?
7.
7. The c value is the number that's sitting by itself. 15. And again, I'm going to write or. You could also write negative 3x plus 7y equals 15. Again, I don't care if you have this or this, as long as your variables are on the left, numbers are on the right. Are we good for 19? Flip when you're ready. That's how I know we're all ready to go on. So we're going to do this page and then we're going to be done. Okay? And part of the page is going to be easy because it's solving systems, and we do that right on the Chromebook, and it's pretty fast. So we shouldn't be too much longer. You should get a little break at the end here. Okay, next thing is slope. Ooh, does anybody remember the slope formula?
y2 minus y1.
Yes, y2 minus y1 over,
x2
yes. Yep, that's my formula. This is my slope formula right here. Super important formula, definitely one that if you had it committed to memory would be a good thing. All right, so now I'm going to label my points. I'm going to label one of them x1, y1, and I'm going to label the other x2, y2. It doesn't matter which is which, but do you see how my little subscripts are the same for this point and then the same for this point? That's what needs to happen. Okay, let's plug in our numbers. So y2 I have as 5 minus y1. Oh, wait. No, I don't. Jeez Louise.
Nuh-uh.
Nuh-uh. Okay. Let's try that again. What is y2 actually?
5.
No.
Wait. No, it's not.
If you're Miss Vessel, it's 5.
It's negative 1.
If you're a smart person, it's negative 1. Okay, minus y1. What's y1?
3.
I was going to say, somebody help me. Leo, help me. Need Leo again. X2 is 5.
That's the 5.
That's the 5 minus x1, which is 0. All right, so if I have negative 1 and I take away 3 more, what am I at? Negative 4. Over 5 take away 0.
5.
So this is my slope. So you leave it as a fraction. Sometimes it comes out that you can you know, divide it and it's a nice number, but not usually. Okay, ready? Next one, slope-intercept form. This is the one you guys were telling me a minute ago when I asked for standard. This is y equals mx plus b. This is the one we see a lot more often, right? So we've got y on the left and everything else on the right. That's how I think about this one. Y on the left, everything else on the right. So again, that's the note I would write to myself so I remember. Okay, so look at our equation for 21. Y is on the left, but what else is with it that I don't want? 3x. So how can I move that away? Yeah, let's subtract it. We always do the opposite, right? Oops. All right, so I've got just y on the left, which is what I wanted, equals negative 3x, because I subtracted it, so now it's negative, and then I still have that 9, and it was positive, so it's plus 9. Is that in the correct form? Yeah. We've got y on the left and everything else on the right. So this is my answer. Y is on the left, everything else is on the right. Okay, so m is your slope. So what's my slope in this equation?
-3.
Negative 3, good job taking the sign with it. And then b is your y-intercept. So 9. How do we feel about that one, okay? Good? Okay. We're going to switch gears and we're going to go to the Chromebooks. So take your Chromebooks, open them up. I don't know if we're going to do all A, B, and C, but we're going to do at least one or two of them. Rude. I brought everybody else one. Usually I do that to Olga too. It's usually the one that I leave out. The poor soul. Poor unfortunate soul. Now I've got that song in my head. Oh, okay. So turn on your Chromebook. So I think we're only going to do part A on this one. There's a bunch of parts, but I think we're just going to do one of them. Oh wait, I don't even want that. I just want abs. What am I doing?
What are you doing?
Who knows? One can never tell.
I don't know.
I don't know. Okay, so we're just going to do one together because, like I said, for sake of time, and we've done so many other things, we're going to do just the first one. So take a look at just the first one. Do you see how one of my equations is 2x plus 7? Type that in. So 2x plus 7. You don't even need to type in the y, just 2x plus 7. Now, do you see how we have another equation? Let's click in that box, and we're going to type in our other equation, which is 2x minus 4. Actually, maybe we will do the others because they are different cases. Yeah, I do want to do all of them. Okay. Taking a look. Do they have an intersection at all?
Do they
No.
bump into each other?
They don't bump into each other, so this one's no solution. And I lied to you. We are going to do all three because they are. I knew they were 3 different situations, but I just, yeah. Okay. No solution. I know. I'm just processing
We're
this
good.
as I go.
We're fine.
We're fine. All right, look at part B. Do you see how for part B, it's not y equals for the top one? So I can't type it in all nice. So we need to first fix this. This needs to be fixed. All right, so we've got 4x plus 2y equals negative 8. We need y to be alone. How can I move away the 4x?
I
Well,
heard someone say something.
not divide. We're gonna subtract it over to remove it. We're gonna divide in a minute, but we're not there yet. So this gives me negative 4x, because this was a minus, and then minus 8. So everything on that side is negative. How can I get y alone? What do I need to do? Yeah, divide by what? 2. So everything gets divided by 2. So negative 4 divided by 2 is negative 2. Negative 8 divided by 2 is negative 4. Okay, now I'm not even going to type these in. Look at these two equations. What are they? The same. If I graph them, they're going to graph right on top of each other, aren't they? So this is an infinitely many solutions. And again, you might not remember this when you're taking the exam on Monday or Tuesday, whenever you get to the, or sorry, Tuesday or Friday, whenever you get to this part. So maybe you remind yourself the reason that this happened is because my equations are the same. So because the equations are the same. All right, part C, do I have to play that game of switching things around? Or are they both y equals? They're both y equals. Love that for myself. Okay, so I'm going to delete all the stuff out, and I'm going to type in these two equations. So one of my equations is 3x, and the other equation is negative 3x plus 2.
Almost the same.
Ooh. Do they intersect? Yeah, let's hover and see where that happens. 1/3, comma 1. So my solution for this one is 1/3, comma 1. And for this entire problem, what was I using on my Chromebook? Desmos. So I'm going to write myself a little friendly reminder, because if I get to test day and I'm like, what did I do here? Like, how did I come up with these answers? I use Desmos. These are Desmos problems. Okay. Let's go down here. We're going to do 2 more and call it a day. You should have a couple minutes at the end to yourself to digest all this. It's been a lot. Do you remember that when we're solving a system, if we use algebra instead, we want 2 of these to be the same except opposites?
Yes.
Okay, so we're going to add these equations together. Negative x plus x. What happens to those? They cancel out. So if I have a negative x plus x, those cancel. 1y minus 5y's. Negative 4y. So be careful with your sign. It should be negative 4. Equals 5 minus 9. Negative 4. To finish solving, what do I need to do to each side? Yeah, divide away your negative 4. Oh, no, you leave that on. That'll be
Yes,
perfect.
I just turned it to face the other.
That's, oh, I love that. Oh, okay. Negative 4 divided by negative 4 is? Ooh.
Negative divide.
1. When you divide something by itself, it's 1. Okay, you can ignore where it says Thursday. That's just me writing notes to myself. All right, so I'm going to plug this back into either of the equations. It doesn't matter which. I'm actually going to go the second one. So we've got x minus 5 times y. Well, what do I know y is? 1. So x minus 5 times 1 equals negative 9.
Do you want these out? Are you saving them for other hours, or are you going to put them back in the morning? Or shift them?
Maybe shift. Let's do a horizontal shift. Okay, negative 5 times 1 is what?
Negative 5.
And how do I get rid of that minus 5 and move it?
You have to pull it.
Yeah, we're gonna add it to the other side. So x equals -9 plus 5. Ooh, not 14, -4. Because look, so it's like 5 minus 9 is what we did there. So we need both of those parts. So remember, that was the tricky thing for these, is that you need an x and a y for your solutions. Okay, look at part B. Do I have two things that are the same, but are the signs opposite?
No.
No. So here's what I'm going to do. I'm going to pick one of them. Doesn't matter which one. Remember, we could multiply by things. I'm going to multiply everything by -1 because that's going to make things the opposite for me. So the top equation, I'm going to leave 5x plus y equals 0. The bottom equation is going to become -5x minus 2y equals -3. So it switches all my signs. So they were all positive, now they're all negative because I multiplied by -1. And now we do the same thing we did for part A. Let's add them up. What happens to my x's? They cancel out. Lovely. 1 take away 2.
That's -2.
Yeah, just -1.
-1.
0 minus 3.
Is,
Yeah. If -y equals -3, then what would positive y equal? Yeah. So that's my answer for y, but I still have to find x. I know. So close. So far. All right, I'm going to plug into the top equation because that one looks a little bit easier. So I have 5x plus, in place of y, I'm going to put 3, equals 0. How can I solve for x? Let's get rid of the 3 first. Yeah, let's subtract it over so it's gone. 5x equals -3. How can I get rid of the 5? Divide.
this is not gonna even.
It's not a nice number, but you can leave your answer. You can just leave me the fraction. If you wanted to find the decimal on your calculator, you could too.
Now we're done?
Now we're done. Yeah, it was a long one today. Thanks.